You've probably already done it today. You flick a switch on an electric kettle, and a few minutes later, you've got boiling water. It seems so ordinary, right? But believe me, hidden inside that simple appliance is an absolutely incredible story of physics and innovation. So let's pull back the curtain on this kitchen marvel and really dig into the hidden science that makes it all tick.
I mean, really think about that for a second. There's no software, no complex computer chip inside. It just heats water to a very specific temperature, boiling, and then it just stops perfectly every single time. How does it do that? Well, today we're going to unravel the science behind what is genuinely one of the most brilliant and efficient devices you have in your entire home.
You know, to really appreciate the genius of the modern kettle, we first have to jump back in time. Back to when boiling water wasn't a simple flick of a switch, but a slow, inefficient, and pretty demanding chore.
Before electricity, if you wanted hot water, you were boiling it over an open flame or a stove. And it was a total game of patience and waste. I mean, most of the heat just escaped into the air, not into the water, and you had to stand there and watch it constantly. But then came the electric promise, this amazing idea that you could create heat exactly where you needed it, do it fast, and have it all happen automatically. So as homes started getting wired for electricity in the late 19th century, inventors, well, they got busy. The very first electric kettles started popping up in the 1890s. The only problem? They were terrible. Yeah, they worked by heating a totally separate compartment underneath the water, which meant that most of that precious heat just radiated away into the kitchen. Honestly, they were barely any faster than a regular stovetop. But the basic science behind it was solid. It's a principle called joule heating, and it's the absolute core concept here. All it means is that when you run electricity through something that resists it, a resistor, that resistance basically forces the electrical energy to turn into heat. It's the exact same thing that makes your toaster elements glow red hot. So those first kettles, they had the right idea, they just had the completely wrong way of doing it. It would actually take a few more decades for the first major breakthrough. And it was an idea so simple and so incredibly effective that it completely changed the game forever. And this was it. This was the light bulb moment that finally arrived in the 1920s. Engineers realized that heating the metal under the kettle was just so wasteful. The real goal was to get the heat source inside the water itself, and that thinking led to the invention of the immersion heating element.
The genius of immersion heating really happens in two physical steps. First, you've got conduction. The hot element passes its energy directly to the water molecules that are physically touching it. But then, and this is where the magic happens, a beautiful, natural process called convection takes over. The hot, less dense water rises, and the cooler, denser water from the top sinks down to take its place right at the heating element. This creates this perfect, automatic, self-stirring current, making sure all the water heats up incredibly fast and evenly. The kettle had finally become practical.
Okay, so the kettle was now fast, but it was also dangerous, really dangerous. There was nothing to stop it from just boiling dry, overheating, and, potentially starting a fire. The solution to this is, and I'm not exaggerating, a true piece of mechanical genius.
And the key thing to remember here is that this problem was solved long before microchips or digital sensors were even a dream. The kettle had to somehow know when water hit exactly 100 degrees Celsius using nothing but the basic laws of physics. So, how on earth did they do it?
It's all thanks to steam and this unbelievably clever little device called a bimetallic strip. See, when the water finally boils, it produces a powerful jet of steam. That steam is channeled up a small tube and aimed directly at this little strip, which is made of two different metals fused together. Now here's the trick. Those two metals expand at different rates when they get hot. This forces the strip to physically bend, and that bend is just enough to literally flick a switch and cut the power. That satisfying click you hear when your kettle's done, that's it. That's the sound of physics at work.
I mean, it's just so elegant, isn't it? It's not smart because of a computer chip, it's smart because of physics. It literally uses the very thing it's trying to achieve, steam from boiling water, to turn itself off. It is a perfect self-regulating system. All right, let's fast forward to today and see how all this innovation led to the modern kettles we use now, which have basically perfected everything from safety all the way to mind-blowing energy efficiency.
Modern kettles are just marvels of material science. We use things like stainless steel and special borosilicate glass because they can handle massive, rapid temperature swings without breaking a sweat. The plastic for the handle and base keeps you safe from the heat and the electricity. But the coolest part is inside the heating element itself.
It's packed with a powder, magnesium oxide, which is an amazing thermal conductor but a terrible electrical one. So what does that mean? It means the heat gets out into the water, but the electricity stays safely locked inside. It's just brilliant. And all of this incredible design and material science leads to this one staggering number. Modern electric kettles are up to 90% energy efficient. That means almost every single bit of electricity it pulls from the wall is converted directly into heat inside the water. There is almost zero waste.
And that 90% figure is even more impressive when you put it up against the other ways you might boil water. A microwave? That's only about 60% efficient at heating water. And a gas or electric stovetop? That can be as low as 40% because so much heat just escapes around the sides of the pot. When it comes to just boiling water, the electric kettle is the undisputed, undefeated champion of efficiency in your kitchen. It's not even a close race.
So what started out as this slow, inefficient, and frankly pretty dangerous novelty has evolved piece by brilliant piece into a masterpiece of simple, effective engineering. It's a journey from a deeply flawed concept to a device that is almost perfectly efficient.
So the next time you're in the kitchen and you hear that click, just take a second to appreciate it. You're not just hearing a switch flip off. You're hearing the culmination of Joule's law of heating, the principles of convection, and the clever, clever application of thermodynamics, all working together in perfect harmony just to make your morning cup of tea. It's a quiet little reminder that sometimes the most profound science is hidden in the simplest objects all around us.